Okay, so we're going to have a go at these two questions. So for the line y equals 4x cubed, take 3x to the 4. What are the greatest and least values on the interval from -1 to 2? And we're also going to talk about where the interval, what is the interval where the graph is concave up? Okay, so we'll start with question 1. Okay, so where could the greatest and least values possibly be? The stationary points and the beginning and the end of the bounds. Okay, so we have a couple of situations. I'll just do a little bit of a sketch over here. We could have, if these are the start and the end of our bounds, we could have a situation like this. Okay, which in this case, the greatest value is a stationary point and the least value is a stationary point. Or we could have a situation like this, where we have a couple of stationary points which are here and here, but in fact the greatest and least values are on the bounds. And obviously we could have a combination of these, okay, but these are the only possible points where a greatest or least value could occur. If it doesn't occur, well, it's got to occur at these points. So we're going to need to find the stationary points, and we're going to need to find those bounds. With regards to the stationary points, we normally find the nature of those stationary points. Is that necessary here? No, it's not necessary. We only need to find the greatest and least values, because if we sub those stationary points in, we're going to find the x's for the stationary points. Okay, let's say I find the x of this one here, and it is going, let's say it's, I don't know, 2 and 6, okay? I know if I'm going to compare it, there's going to be no of these other points are going to be greater than 6, okay? Just simply because of what the graph looks like. So in that case, you know, my greatest value has to be a 6. So there's no need to do the double derivative in this question. There's no need to do the nature of the stationary points. Okay, so let's have a go at this one. So first we'll sub in our bounds. So we'll do our bounds first. Okay, so we have our bounds as -1 and 2. Let's say at -1. Y is equal to 4 times -1 cubed. Take 3 times -1 to the 4. That's -4. Take 3, which is -5. And at x is equal to 2. Also equal to 4 by 2 cubed. Take 3 by 2 to the 4. So that's 8 times 4 is 32. Take 48. So is that -16?
Yeah.
4 times 2 cubed, take 3 times 2 to 4. -16? Okay. So we've got these two values for our bounds. There's always going to be two bounds. Now I'll just add in to what I was saying here. This could change if we had some sort of non-continuous function. So, for instance, if we had bounds, so for instance, a hyperbola, okay, could look like this, okay, and the greatest and least values would be negative and positive at infinity, and you could have some sort of combination. This is not something we're needing to worry about, okay? We've been looking purely at polynomials, so polynomials is where we'll stay. So I'm just saying this doesn't work for all functions, these two situations, but it does for all polynomials. Yes?
I don't think -5 is correct. Yeah.
Well,
It's negative. So -4 take.
Thanks. -7, you're right. Alright, okay, so then we need to find our stationary points. So I'll come over here and do that. Stationary points. What do we need for our stationary points? What do we need to find first? The derivative. So I'm going to come back up here. I'm just going to add the derivative up here because I like to do that straight away when we have a function. So that's going to be 12x squared take 12x cubed. So for our stationary points, that's off screen, sorry about that. For our stationary points, we let what? Y dash equals 0. So we have 0 is equal to 12x squared take 12x cubed. In your bracket there. So to solve that, what's the easiest way? Factorize it. So I can take out 12x squared, get 1 take x. So I have 12x squared equals 0, and 1 take x equals 0. So I have x is equal to 1, and x is equal to 0. So I have stationary points, those 2 points. So I need to take these x values, so there potentially could be maximums or minimums at these points as well. So I'm going to say, well, at x equals 0, y is equal to 4 by 0 cubed take 3 by 0 to the 4, which is obviously 0. And at, obviously on screen, at x is equal to 1, we have y is equal to 4 by 1 cubed take 3 by 1 to the 4, which is which is just 1. So we have our 4 values here. We've got -7, -16, 0, and 1. So what's our least one? -16. So our least value, -16, and that occurs at x equals 2. Now greatest is 1, and that occurs at x equals 1. Okay, so one of them was a stationary point, one of them was a bound. Any questions about that one? Okay, I'll stop there and we'll do a concavity question next.